So, good afternoon, everyone. So, let me first introduce myself. I am Rahul Singh, working as a staff software engineer at ARM, and I am currently working on Zen. So, today in this presentation, I will tell about the PCI device pass-through status on ARM. So, this is the feature that we have been implementing with EPAM. So, let's okay. So, this is the feature that we have been implementing with alongside with EPAM from the last 1 years. So I will explain about what is the current status and how we'll merge the rest of the part to the Zen. Next is the another feature that we have a POC that is for supporting the PCI device pass-through for the system that boot with ACPI. Another feature that I have been implementing is the SMMU version 3 nested translation support. And then last two are the demos for both the feature. One is for ACPI PCI pass-through and another one is the SMMU version 3 nested translation. So before I will go through the status of the PCI device pass-through, let me just give a brief overview what is the PCI device pass-through. So as you can see, this is the high-level design for the PCI device pass-through on ARM. So just take an example for the DOM 0. Let's see, we have a two host bridge on SoC that is exposed to the DOM 0. One is host bridge A and another one is host bridge B, and there are two devices attached to each host bridge. We have a physical ITS that is attached to the each host bridge that will help to inject a MSI interrupt, as a physical ITS is required on ARM board to injecting the MSI interrupt to the guest or hypervisor. So for as you see as a for DOMU systems, DOMU systems we will create a virtual ITS and a virtual host bridge, and we will attach, or when we assign a particular device to the guest, we will attach those devices to this virtual host bridge, and we will create a virtual BDF for these devices. And for configuring the device, we will trap the access to the PCI config space from the DOMU guest, and same thing for virtual ITS also. We will trap the access to the virtual ITS, and we will configure the physical ITS accordingly to inject an MSI interrupt. So this is a high level design, and we have presented this feature in the last Zen Summit. So this is an overview. So this is the current status of the PCI device pass-through. So initial patches are merged to Zen, and that includes the PCI host bridge discovery for the system and the virtual PCI support for ARM, and other functions that is to access the PCI devices and PCI config space. There are patches that are currently in review that is mostly from EPAM. Those are the one is the PCI device locking. That is the prerequisite patch for other patches. Yeah. So once that is merged, then we will try to merge the other patches. The another patches are for non-identity PCI bar mapping. In this, whenever we the Zen traps the PCI config space and the for PCI command is changed, we will map the bars to that DOM 0 DOM U. And another patch is for that virtual PCI bus topology. We will create a virtual PCI bus for the DOM U guest. Once those patches will be merged to the Zen, we will start upstreaming the other patches that is related to MSI and MSI X interrupt, and adding a PCI device to the IMAB subsystem. So that is not support, as you know, as of now not supported for ARM. So this is another proof of concept that we have been doing for to support the PCI device pass through for system that boot with ACPI. So in that case, how we did implement that one? So we need to pass the MMFG table to get the host bridge. So mostly we have used the x86 code that is currently available and modified it for ARM. Yeah, and we need the FG table to get all the information for where is the PCI config space, where are those bars that we needed. And another things we have to modify the IMMU subsystem code to add support for ACPI devices. That code is not available as of now. We implemented that one. The third one is we need to add support for SMMU version 3 ACPI boot. So currently SMMU version 3 driver in Zen only support booting with device tree. So we have added this support also in this POC. And last one is the parsing the IOR table. IOR table is only for the ARM subsystems. So that include information between the PCI host bridge and ITS and SMM version 3 mapping. So which host bridge will send an interrupt to which ITS, and which SMM is connected to the which host bridge. Those information are in the IOR table. So we'll parse this IOR table and configure the Zen accordingly. So this is the POC that we did. I will show the demo, yeah, later. So yeah, this is another feature that I have implemented for the SMMU nested translation. So before I will explain the feature, let me just give a brief overview what is an SMMU. So SMMU is like an MMU, but it will translate the address for DMA request from IO devices. And it will provide isolation within the OS or between virtual machines. For SME version 3 support two stages of translation. One is stage 1, that is translating from virtual address to IPA, intermediate physical address, and it helps provide isolation or translation to buffers within the OS. Another second stage is the stage 2, that will be configured by the hypervisor, and it will translate the IPA to the output physical address. So stage 2 is required for the system supporting the virtualization extensions, or you can say that is VMs, and it will provide isolation or translation between virtual machines. Stage 2 translation. So yeah, SM version 3 can support both stage 1 and stage 2. And gas, in this case, gas should handle the stage 1 and hypervisor handle the stage 2. As of now in Zen, we only support stage 2 translation. There is no support for stage 1. So if you see as a whole, if we don't have stage 1, drivers running in the Linux or OS will configure the IPA to the device for DMA. But if we support stage 1, drivers in Linux or OS will configure the virtual address to the devices. And SMME version 3 will translate those virtual address to VPA via stage 1, and stage 2 will translate those addresses from IPA to the output physical address. So we have added that support, and this is the high level design how we added that support. So stage 1 configuration, that should be handled by guest. So that should be configured within the guest to provide isolation between software entities. So yeah, so that device cannot do like corrupt the other part of within the guest. So if we add this support, we will avoid those things, and guest will get the full ownership of the stage 1 configuration. We cannot trust the guest OS to control the whole SMMU hardware. So Zen will take control of the stage 2 configuration, and configure within the guest to provide isolation between VMs. Zen handle the root configuration structure for security reasons, including stage 2. So we have created a virtual SMMU version 3 emulated virtual SMMU device for DOMU and DOM0 guest. Guest can use the native SMMU driver to configure the stage 1 translation. Zen will trap all the access to the virtual SMMU and will configure the hardware accordingly. All the translation fault that will happen in the real hardware for stage 1, that will be injected into the guest. This is the high level design to support the SMMU version 3 nested translation. So if we add this support, then guest or DOM0 guest or DOMU guest will configure the stage 1, and they can configure the virtual address for DMA transactions into the device. And when device will start doing the DMA transaction, SMU version 3 will convert those addresses accordingly. So now I will show the demo. Yeah, okay.
Click on your screen on the little image of your screen.
Here.
No, no, no. A little bit further up in the center.
Okay.
Yeah, there.
So this is the demo for the SME emergency nested translation, and I have recorded this demo on the N1 SDP board. So let me play the video. It's already started. Sorry for that. Yeah. So now the system is booting. It's not. Yeah. If we go to the Zen booting logs here, you can see SMMU version 3 has been probed. Then there are two SMMU version 3 on this system, and here the one PCI host bridge that is probed correctly. So now when the Linux enumerate the PCI device, it will inform Zen to as those PCI device, and stage 1 will be stage 2 translation for SMA version 3 will be configured here. So now stage 2 is configured correctly. Now here you can see this is the virtual SMMU, and Linux driver able to find the virtual SMMU, and it is added to one of the MMU group and devices, and all the other devices added to MMU group 3. So Linux is able to detect the virtual SMMU, and it configure the stage 1 for those devices. So now I will try to assign one of the PCI device to the DOMU guest. I think 1 second. Yes, I think. Yeah, sorry. I think it's gone. I'm sorry. So I will try to assign this Ethernet device to the guest. So I will use the current Excel command, Excel PCS enable add, to add that device to the PCI back driver. So now it is added to the PCI back driver. So this is the guest config, and here you can see I have added the PCI that device in the PCI configuration. Yeah. Now I will create the guest. Now guest is booting, and here now you can see this is the emulated PCI host bridge, and that device is attached to that emulated host bridge. And here you can see the virtual SMMU, and here again that device is added to the IMMU group 0. That means stage 1 is configured correctly for that device. So now I will try to assign a IP to that Ethernet device via DHCPD, and it will get that IP. So here you can see it got the IP correctly, and I am trying to now ping to the google.com. Yeah. So now you can see that the DMA transaction, all those things is working fine with the stage 1 and stage 2 both supported. and yeah, it supports, here you can see it supports the SMMU ITS MSI interrupt for each zero device. Here MSIX enable is plus, yeah. So now I will play another video that is for ACPI PCI support. So here the system is Ampere Ultra Ava board that I have been used. So yeah, this is the system that we have been using now for testing the PCI pass-through, and it has around 5 to 10 host bridges, and yeah, in each host bridge has 2 3 devices attached to it. So now if we go to the Zen boot logs, you can see the system is booted with ACPI. So now here you can see the ACPI logs, and yeah, this is the we are parsing the MMCFG table to get the information for the PCI host bridges. So now SMU version 3 is also proved with ACPI support, and there where we have around 5 host bridges on this board. So here device are PCI device added to the Zen, and SMU version 3 stage 2 is configured, and we pass the IO table to configure the SMU version 3 and ITS. So yeah, here you can see this SoC has around 5 segments, and each segment has any device attached to it. This is the good platform to test the PCI pass-through feature. And now I will try to assign a GPU to the guest, and one Ethernet device and one NVMe device to the guest. Now this is the configuration for the guest, and I have, if you can see the PCI thing, here we have added all the 3 devices. Now let's create the guest. Now I'm trying to log in into the guest, and here the guest booting. So if we go up, you can see the emulated virtual PCI host bridge and all the 3 devices attached to that bridge. So NVMe is proved fine. Another device is also proved fine. And yeah, Nvidia driver also proved fine, it's configured correctly for that GPU that we have passed through to this. So this is the simple test for testing the. So you can see here MS Enter for Nvidia is working fine. So this is the test I will be doing on Nvidia driver. This is a simple test. So we'll run the script and it will tell whether this Nvidia driver is working fine or not. So this is the test for the another device that we have assigned for the Ethernet. It will get the IP from the DHCPD. Yeah, it got the IP. I think that's all. Now, any questions?
Yeah, there is one question from Mirai. Is SMMU v3 a requirement in your nested SMMU implementation? SMMU v2 also has support for both stages of translation. So is SMMU v3 a hard requirement or can we also support SMMU v2?
So as of now, we are supporting for SMMU v3 only,
Yeah.
but we can support SMMU version 1 also.
Yeah. Okay. Rahul, is it answering your question?
Yeah, thank you very much, Rahul.
And then there is Alexander, well, that's not really a question, but thinks that the nested translation is quite interesting. And he thinks that technically the idea could also be supported on your card GNC, IPMMU with also the MSA compatible.
Yes.
Yeah, definitely that's true, Alexander. It can be supported there.
Yeah, that can be supported Alexander, and yeah, we have not. Yeah, we have created the implemented the code in such a way that can support any IMMU device.
That's it for the question for now.
I think that's it. Yeah, that's it.
That's it.
Yeah.
Thank you, Rahul.
Thank you.